All right, so let's take a look at lesson number 9. Lesson number 9 is equations and inequalities in two variables. And specifically, we're taking a look at equations and inequalities in two variables and their graphs. So mostly just looking at their graphs here. So the first thing we're going to do is look at equations of lines and match those with their graphs. And then take a look at the inequalities and match those with their graphs as well. So this should be review. There's a couple things that we're going to remember as we go through here, and then I'll also show you again on your calculator how you can go about graphing these as well. So it starts off with, if a linear equation has two variables, its solutions are ordered pairs of numbers. For example, x plus y equals 6 is an equation with two variables, right? So it has an x and a y. And its solutions are all pairs of numbers for x and y. So one example, right, for one solution is 0 and 6, right? So 0 being our x value, 6 being our y. If we were to substitute that back into our equation, it'd be 0 plus 6 is equal to 6. That's true. Same with our next point here, 2, 4. If we did 2 plus 4, that's 6. 3 and 3, 3 plus 3 is also 6 here. So to find the solution, first rewrite the equation in an equivalent form with one variable, often y, isolated to the left. So what they did here, right, is they just took x plus y equals 6, and they got y by itself by subtracting x from both sides. So we have y equals 6 minus x. Then it said here to find another value of this, right? We can just write it as, pick any value of x, right? And we'll find the y value. So here they chose 5, so they substituted in 5 for x. 6 minus 5 is 1. So the y value equals 1. So when x is 5, y is 1. That's also a solution. So going on here. For any equation in two variables, a solution is an ordered pair in which each number is substituted into its corresponding variable to make the equation true. The solution set of an equation in two variables is often all the solutions of the equation. Each ordered pair in the solution set corresponds to a point when graphed in the coordinate plane. The graph of the equation is the set of all such points in the coordinate plane. Really what they're saying is that when you have one equation and two variables, the solution to that equation is all of the points that make up this line here. So this line was x plus y equals to 6, and the solutions are every single point that's on this line here. So we could pick a point here, all right, 1, 5. That is a solution, all right, and we can just keep going through all of these lines here. So we've done this, right? These are graphing lines. Specifically, we're going to take a look at how we would graph this line. So if we were to write an equation for this line, say we weren't given an equation, and we need to write an equation, this is where our famous y equals mx plus b formula comes into play here. This is the slope-intercept form of a line, where m is our slope, which is the rise over the run, or it could be how much we go down over the run. And then b is the y-intercept, which is where the line crosses this y-axis. So we have our axes here, which I'll highlight in pink. And we have our line, which I'll highlight here in green. So to find the slope, we pick any 2 points on this line. So I'm actually just going to start from here and go to our next point right there. And we say, do we go up or down? Well, for our slope, we go down. And how much do we go down to get to this next point? We go down 1. If we're going down, it's negative. So negative 1 over, how much do we go to the right? 1, which means that our slope is -1 divided by 1, which is -1. And then our B, our y-intercept, is just where we cross the y-axis. So this green line intersects with our pink line right there at +6, so B equals +6. And then our equation, we just fill in our y equals mx plus b with a slope that's equal to -1x plus b, which is 6. So the slope of this line here is y equals -1x plus 6. So now if we take a look at sample 1, sample 1 just wants us to see which graph has this equation. So here, again, we have our 3, which is the slope, right? So in this one, our m is 3. If we want to write this as a fraction, we can write it as 3 over 1, which means we go up 3 over 1. And then our +1 here is the y-intercept, which is our b. So b equals 1. All right, this is also where we start. All right, so we start at the y-axis at +1. So if we look at both choice A and C, we see they both cross the y-axis at +1. So that means there's a good chance that it's going to be this line here. Then if we take a look at the slope, so we can cross off B and D, take a look at the slope of these lines. So pick any 2 points. So I'm going to start from here to here and see how much do I have to go up and then how much do I go over. So to get from this point to our next point on this line, we go up 1, 2, 3. So we go up 3 over 1. So this has the same slope as our equation here. So our choice is choice A. If we look at choice B, we notice that this line here, if we're going from left to right, we go down 1, 2, 3. So down 3, which is -3, to the right 1, which is the slope of -3 over 1, which is not the same as our equation that we had up here. Now, another way to go about this is to take a look on your calculators. All right, we can also take a look at this problem on the calculator. So if you turn on your calculator, right, which if you don't have, you have access to on your computer there by signing into the virtual desktop. And we go to a graph, so choice B. Actually, I'm going to do home screen. Let's do 1, saying no. Then a new graph. Up here, if it's solved, if our equation is solved for y, right, we can plug it right into the calculator as it is. Instead of writing y equals though, we keep it as f of x equals. Then we're going to plug in 3x plus 1. We hit enter, and we're looking for the graph that matches ours. If you take a look here, we can still see which one of these looks the same. Well, this is going in the direction of choice A and choice B. However, it crosses above the origin, like this one does, so we'd pick choice A. All right, so let's take a look at the next part here. So now we're going to get into inequalities. So inequalities is a little bit different, but some of the things are exactly the same. So when an inequality involves 2 variables, its solution is best represented on the coordinate plane rather than on a number line. Graphing inequalities in 2 variables is very similar to graphing equations. So consider the inequality y minus 2x is greater than 1. And then by adding 2x to both sides, you can write this inequality as y is greater than 2x plus 1. So, right, if we had our inequality y minus 2x greater than 1, if we wanted to solve this for y or get y by itself, add 2x, then we have y is greater than 2x plus 1. Once we have something like this, right, this should be familiar because this is similar to when we have the equation y equals 2x plus 1. We can go about graphing them or starting to graph them in very similar ways here, right? So we still have a slope of 2 and we have a y-intercept of 1. The only thing that's going to be a little bit different is how we treat this greater than symbol here. So when you flip over to the next page, you take a look at the two graphs that they made. So the first graph here is y equals 2x plus 1. So if you notice our slope and our y-intercept, right? So we start at 1, and then to get our next point, we go up 1, or sorry, the slope is 2. So it's 2 over 1, so we go up 2 to the right 1. So starting at our y-intercept, we go up 1, 2 to the right 1. Up 1, 2 to the right 1. Can draw our straight line here. Now, when you take a look at this one here though, right, we have our y-intercept, which is still at 1 here, and we still go up 1, 2 over 1, up 2 over 1, right, to create this line here. But when we have our inequality that is greater than, or if it's less than, so if you take a look over here, less than or greater than do not include the line. So when we say do not include the line, that means that it's going to be dashed, right? So less than or greater than is dashed lines, but when we have greater than or equal to or less than or equal to is when we have our solid lines. Now in class, how we determined to shade above this line, right, was we took our test point here, which was 0, 0. We always tested the origin, and we plugged in the point 0, 0 into our inequality to see if it was true. So 0 is greater than 2 times 0 plus 1. Is 0 greater than 2 times 0, 0, 1? Is 0 greater than 1? We would say false, and we would shade above, or we wrote no, right? And that is how we determined that it was greater than. Now again, using our calculators, we can go through and graph this. So again, new, no, graph. Now the difference here is that we don't have an inequality that we can just type in here, all right? So it's not, we can't just type in f of x, is sorry, what I'm trying to say here. So what we have to do is we have to delete what we have here and put in the relation that we're given. So for this one, we're looking for y is greater than. So we hit enter, y is greater than 2x plus 1. We hit enter, and it will graph our inequality. Now this one, it is a dashed line here, but it's a little hard to see, so make sure that you're paying attention to your inequality sign there below, but this can help you to see where to shade above or below the inequality line there. All right, if we take a look, they go through and they show a couple more examples here. So when we take a look here, again, I'm going to highlight our other one that was not a solid line. So if you notice that dashed line there, because this was y was less than 2x plus 1, right? And then if we took that test point here of 0, 0, plugged it in, 0 is less than 2 times 0 plus 1. 0 is less than 1. That's true. So we could say yes, and then shade below the line, right? Same as if we put it in over here as 0, 0. We test it out. 0 is less than or equal to 2 times 0 plus 1. Is 0 less than or equal to 1? That's true. So we can shade below. Also notice here how when we have our less than sign, it's solid. So solid there. Again, less than or equal to sign, sorry. On this one, greater than or equal to is going to make it solid as well. If we're testing the origin, at 0, 0, plug it in here. 0 is less than, or is greater than or equal to 2 times 0 plus 1. Is 0 greater than or equal to 1? No. And we shade above. All right, so these are all things that we did in class here. So let's take a look at this last part here that says, for an inequality in two variables, a solution is an ordered pair if, when each number is substituted into its corresponding variable, the inequality is true. So the solution set of an inequality in two variables is all the solutions of the inequality. Each ordered pair in the solution set corresponds to a point when graphed in the coordinate plane. The graph of an inequality is the set of all such points in the coordinate. So a half plane is the graph of a linear equality in this coordinate plane. So different from when we have a line. A line, all of the solutions are on this line here. Right? When we're talking about an inequality, the solutions are anywhere in this shaded region. So this point here is a solution. This point here is a solution. Now, if it is a dashed line, the points on the dashed line are not part of the solution, right? Because it's not equal to that line. And either are points here. That is not part of the solution, right? Because it's not in that shaded region. So when we look down here, a point in the solution can be up here, can be over here, over here. In this case, it's greater than or equal to, so that also includes our points on the line. They are also part of the solution set. But again, any points outside that are not shaded, that is not a point in the solution set. So taking a look at sample question, it says, which inequality is graphed below? So first thing we want to look at is our line here. So is that line solid or is it dashed? If you take a close look, it's solid. So when it's solid, it automatically means that it has to be less than or equal to or greater than or equal to, right? If we have dashed, that was when we had less than or greater than. So right away, we see it's solid, so we can get rid of choices A and choices C. Then what we want to do is pick a test point and see which one of these inequalities this test point works for. So I'm going to pick the point over here, 2, 1. Right? So x is 2, y is 1. This is in the shaded region, so it should be a part of the solution. So for this one here, remember these are x and y's. If I plug this in, y is greater than or equal to 2. Is that true? No. So we cross that one off. Let's double check this one. Y is less than or equal to 2. Yes, that is true, which shows that that point is part of the solution, and therefore the choice is D. Another way you could have done that, right, is taking a look on your graph. If you wanted to here, you can graph each one of those. So if we go through, let's do a new one. So we want to graph the first one was y was greater than x. Well, we can still graph it even though we know that it wasn't that one because it's a dash line. On here you can see it's a dash line and it's shaded above, so that's not it. If we want to change that, all right, we can go back, delete it, do the next one, that y. And then if we want to get to our inequality signs, right, we can hit Control equals and do greater than or equal to x, hit enter. We see the shaded part didn't change, but now we don't have a dashed line here. That one's not the same as what we have here. Next one we can do up here. Again, here, just going to delete the symbol. Let's put in our less than sign. So this one here is shaded in the correct area, but if you take a look, you can see it's a dashed line there. And then finally our last one, if we were to figure this one out, equals less than or equal to enter x, which has a solid line and is shaded in the appropriate area. So using your calculator, right, is a great tool that you can use to double check some of your answers here. All right, so taking a look at choice 1. Which point is a solution to the graphed equation? For it to be a solution, it has to be on the line. So you're looking for which one of these points here is on this line. Continue on to the back here. It says Maria created this table of values for the equation y equals 2x plus 3. Which graph shows the line for y equals 2x plus 3? So two ways to do this. All right, one you can do is take a look remembering our slope and our y-intercept. And you'll find one of these lines has a y-intercept of 3 and a slope of positive 2. Or you can also check which points, right, fall onto these lines here. Taking a look at question 3, it says Gordon earns $10 an hour mowing lawns and $15 an hour tutoring. He plans to earn at least $300 a week doing these jobs in the summer. The inequality can be used to find the number of hours he could do these jobs to reach his goal. So they give you the inequality, right? And you need to graph that inequality. One way to do this would be to solve this inequality for y, right? And then see which one of these graphs matches that. Another one is that you can just plug that into your calculator here. So if you're going to do tab, so actually let's show you real quick. So when you're doing new documents, right, get some sort of glare here. And you run a graph. If you delete, right, and go down to relation, so for choice 6 here, right, we can put in anything that we want in here, right? So it doesn't have to be y is greater than, x is greater than. We could just type in 10x plus 15y and then is greater than or equal to 300, right? I'm going to leave it a little bit of a mystery here. You hit enter, you'll find out which one of these graphs matches. Down here, again, similarly, certain things here to notice, right? You're able to find the y-intercept, right? And then find the slope here of this line and see which one of these equations is, or one of these inequalities is shown there in the graph. Taking a look here, question 5 says, Linda purchased some office equipment for $24,000. Her accountant told her that the equipment would decrease in value by $2,000 each year until it had no value. Create a table of values to show the relationship between T and time in years and V the value of equipment. So I'll get you started off with the first 2 points here. So at time 0, when she first purchases that equipment, right, it is worth $24,000. And then each year, that equipment goes down by $2,000. So after 1 year, we'd say 24,000 minus 2,000, and that's how much it would be worth. And then you can go through, continue that table, and then write a linear equation from that table there. Taking a look at question 6. Question 6 has to do with a band that sells CDs for $8 each and t-shirts for $15 each, and Sarah wants to buy some CDs and t-shirts as gifts for her friends, but she can spend a total of $75 at most. So at most, notice how when they did at most here, that turned into a less than or equal to sign. Good thing to take notice of here. So they give you the inequality, 8x plus 15y is less than or equal to 75, where x represents the number of CDs and y represents the number of t-shirts Sarah can buy. And you have to graph this in the coordinate plane below. So when you're graphing this in the coordinate plane below, the first thing we want to do here is solve this inequality for y. So right, so you have 8x plus 15y is less than or equal to 75. And then if we want to get y by itself, right, so we'd subtract 8x minus 8x. So we have 15y less than or equal to negative 8x plus 75. Then to get y by itself, divide by 15. Divide this side by 15, over here by 15. And we get that y is less than or equal to negative 8 over 15 plus, here we'll get 5. All right, so you have a formula that you could start with here, or sorry, x here. So this is one that you can graph here and then provide two different solutions for this inequality. All right, so give this one a shot here. If you have questions, make sure to reach out, and hopefully we'll get some responses here, and then we'll keep going with the next lesson, lesson 10. Lesson 10, we're going to split into two parts, 10A and 10B. So pay attention for that coming soon.